Okay, a very good morning to all. We will start the session now. So we will start with a few housekeeping notes before we start today's program. Firstly, this meeting will be recorded and the recording will be posted on the conference website. And we would like to kindly request everyone to mute your microphone. You may mute or unmute using the microphone button at the bottom of your panel. This is to minimize the background noise throughout this event today. And there will be a question and answer session following the presentation. So feel free to type your questions at any time using the chat box or raise your virtual hand in Zoom to request the floor at the end of the presentation. Please turn on your camera when you speak and identify yourself first by name and organization to help others to recognize you. And lastly, if you have any further assistance in terms of logistics, please go to the chat box and send your message to admin directly. Thank you. And I would like to, a very good morning to our honorable guests, ladies and gentlemen. It is my pleasure to be the MC for today's event. I'm Nitya Nilamani from the Center for Marine and Coastal Studies, and on the behalf of organizing committee, I would like to extend a very warm welcome to all. Thank you for joining the Decade Action Incubator 1 Ocean Solution to understand the multiple stresses on coastal ecosystem and provide solutions that benefit people, nature, and economy. We hope you will find the program we have lined up for you to be fruitful and engaging. Now, with much honor, I would like to invite Mr. Wenzi Zhu, the head of UNESCO IOC Regional Secretariat for WESTPAC, to deliver the opening remarks.
Thank you very much, Lydia. Can you hear me?
Yeah, it's
very good morning. I think, dear colleagues and friends, first of all, I think on behalf of the IOC, UNESCO, and all the conference organizers and partners, a big welcome, to the first incubator session of the regional takeoff events. So first question to you, do you enjoy the current lockdown and travel restriction and virtual working modality? I guess most of people will say no. I think indeed, the global pandemic reminds us, of the inextricable link of the humanity to nature, and also enabling us, despite many restrictions, to rethink and reset the relationship between us and the planet. Of course, ocean, I think, play a very key role in this kind of a rethinking process. I think this is especially true for the region that we are living in. That's also the main reason that we gather together, simply because this region, I think many countries in this region, among the world's fastest growing economies, and also imposing a lot of ever increasing pressure on the ocean. So I think the Ocean Decade launched in a very perfect time, enabling us to work more closely to develop transformative ocean science solution, or using our indigenous knowledge, local mindset, to foster meaningful partnership with a view to addressing many sustainable challenges we have been faced with. So I hope through this 2 days conference, I think you will gain more understanding about the UN Decade, about what's going on, our movement in this region, particularly including from the conference opening that will take place this afternoon. So as we always cite, our journey of all 1,000 miles always begins with a single step. So allow me to extend our very sincerest appreciation and congratulations to our conveners, Professor Eileen from Malaysia, Zalfigar from Malaysia, Malo from Philippines, and all speakers and the organizing committee from different countries on the establishment of this incubator. I truly believe this is indeed a very courageous step forward in concerting the region-wide efforts by brainstorming ideas, catalyzing partnerships, and also towards a solution that can benefit people, nature, and the economy, as the incubator name implies. So needless to say, your active engagement is already part of the solution. So with this, I thank you all again, and also I wish a very fruitful discussion. Thank you very much, Nithya, for your moderating this chairing this incubator session. I give the floor back to you. Thank you.
Thank you, Mr. Wenzi, for the wonderful remarks. Next, we are pleased to invite Professor Dato Dr. Eileen Tan Shao Huai, the Vice Chairperson of IOC-WESTPAC, to introduce to us the Decade Action Incubator 1.
Thank you, Nithya and Wingzi for the introduction. Sim, please do share my slides. I wish to take this opportunity also to welcome all to the Decade Action Incubator number 1, focusing on ocean solutions. Yeah, please allow me to do the introduction to the incubator program. Yeah, this incubator will touch on the topic of ocean solutions, understanding the multiple stresses on the coastal ecosystem and provide solutions that benefit people, nature, and the economy to be in line with sustainable development goals. Next slide, please. The aim of this incubator of ocean solutions to understand the impacts of multi-stresses and their impacts on natural ecosystems and coastal communities. Second is to explore and share the multidisciplinary approaches, findings, and practices on the research and monitoring of multiple stresses and their impacts. And thirdly, to develop a regional network to advance multidisciplinary research and engagement with coastal communities and provide workable science-based solutions to benefit people, nature, and livelihood. This incubator would like to gather all scientists and stakeholders to move forward together to find solutions. Next slide, please, Sim. By providing food security, coastal protection, and other indispensable ecosystem services, natural coastal ecosystems are a critical part of the survival and subsistence of coastal communities. But coastal ecosystems in the Western Pacific, in particular, are increasingly threatened by multiple stresses, including climate change and ocean acidification, ocean hypoxia, eutrophication, sea level rise, and other additional stresses, such as pollution and unregulated local coastal development. All these can be categorized as climate-induced stresses, local anthropogenic stresses, which create compounded impacts and emergent threats, to the ecosystem and communities. Next, please. Most of the research conducted are focusing on single stresses and mainly also lab-based. Traditional approaches of focusing on particular stresses without considering the overall spectrum of stresses on coastal ecosystem has been found to be unable to address the real issues that can help the ecosystem and also the communities. Therefore, a new approach that looks at the whole range of stresses on coastal ecosystem and engaging the local stakeholders in the development of solutions are needed. Next, please. This incubator would like to lead a discussion into finding ocean solutions based on science, using holistic approaches, which involve several steps such as identification of the main study site, identification and prioritizing the main stresses and issues, identifying what is required to improve these ecosystems. How does this benefit the people, nature, and economy? Who is required to achieve this? Who plays a role here? And upscaling through benefits and experience sharing and expanding to new sites. Next, please. There is emphasis on framework that provides solution to environmental threats, which could be implemented on the local scale with provision for scaling up to the regional and international scales. This effort would require a multidisciplinary team with a broad knowledge base and understanding of the need and capabilities of their respective local communities. We hope to truly implement multidisciplinary, and of course, when we are talking about regional collaboration, we will be involving transdisciplinary approaches for solution. Next, please. Through the platform of IOC-WESTPAC. Next, please, see. Through the platform of IOC-WESTPAC and through the discussion in this incubator, we will be listening to the sharing of experience and expertise from various lead scientists from several countries in the Western Pacific region. Member countries have had different levels of success and of course inclusive of failures in addressing issues related to ecosystem protection. This platform will provide an opportunity for members to synergize future efforts to promote and to protect coastal ecosystems and provide a sustainable future to coastal communities. During this session also, we would like to hear the views and recommendations from the member IOC-WESTPAC countries and members of the public who is attending today in this incubator to contribute ideas and solutions to move forward together in finding ocean solutions for the people, nature, and economy. Thank you. Back to you, Nitya. Thank you.
Thank you, Professor Eileen, for the great introduction. And now it is our pleasure to introduce Dr. Erica Tau, the NOAA National Coral Reef Monitoring Program Coordinator, to set the scene of our event today. Dr. Erica Tau joined the NOAA Coral Reef Conservation Program, CRCP, as National Coral Reef Monitoring Program Coordinator in year 2019. She received her PhD in Marine Biology and Ecology with a focus on coral reef ecology from the University of Miami Rosenthal School of Marine and Atmospheric Science in year 2015 and completed a postdoctoral work at NOAA's Atlantic Oceanographic and Meteorological Laboratory. Dr. Tao was awarded the Dean John A. Connell C. Grant Fellowship in year 2016. After completing her one-year fellowship as a science policy analyst for the United States Senate Subcommittee on Oceans, Atmosphere, Fisheries, and Coast Guard, she spent 2 years at NOAA's National Ocean Service as a marine science policy expert before joining CRCP. At CRCP, she is responsible for coordinating research teams to collect and monitor data about the health and state of all 10 U.S. coral reef ecosystems. Without further ado, I will pass the floor to Dr. Erica to share with us the coral reef condition, a status report of U.S. coral reef.
Hello, and thank you to ICRS for the opportunity to present this talk virtually. My name is Erica Toll, and I am the National Coral Reef Monitoring Program Coordinator for NOAA's Coral Reef Conservation Program. My talk today is titled A National Status Report on U.S. Coral Reef Ecosystems based on data from NOAA's National Coral Reef Monitoring Program. During this talk, I will give a brief overview of the National Coral Reef Monitoring Program, which I will refer to as NCREMP for short. I will go over why we chose to make status reports specifically for policymakers. Then I will go over the process by which we scored each U.S. coral reef jurisdiction and share the results with you. Lastly, I'll note our conclusions for policymakers. NCREMP collects geographically comprehensive data in 4 different themes: biological, which includes benthic and reef fish data, climate, and socioeconomic surveys in all 10 U.S. coral reef areas using consistent and comparable methods and standard operating protocols. The biological and climate surveys are done on a 3-year cycle in the Pacific Basin territories and a 2-year cycle in the Atlantic, Caribbean, and Gulf of Mexico territories. Coral Reef Watch data on thermal stress is collected daily via satellites. The socioeconomic surveys are collected approximately on a 7-year cycle only for the inhabited jurisdictions. I won't read this whole list, but the table on the left shows the indicators NCREM collects in the biological, climate, and socioeconomic themes. Using a stratified random sampling design allows NCREM to take a wide but thin approach, meaning our data allow us to say something on an island and jurisdiction-wide scale. NCREM surveys are focused on hard bottom areas between 0 and 30 meters depth. So why did we decide to do status reports using NCREM data? This figure is from our partners on this project, the University of Maryland Center for Environmental Science, UMSES, and it shows different kinds of data products and who the target audience is. For many years, NCREM had focused on that lowest level, just archiving our primary data and metadata that was mostly used by other scientists, and a little bit on some of the middle layers, i.e. technical documents for managers, etc. Until the status reports, we had never had a product aimed at the general public, and maybe most importantly, policymakers. In the US, this is really aimed at United States congressional staff. We felt like it was time to design a report that was geared at policymakers to really convey, in a non-technical way, how US reefs are actually doing. Of course, the irony here is that to produce something that reads as non-technical, you have to do the greatest amount of technical analyses up front. Mentioning how much analytical work went into these reports is a good segue into making sure I convey that this effort included many, many collaborators, too many to list on this slide. These are just some of the key scientists who worked on these reports, but there are many more local experts in every U.S. coral reef jurisdiction who are integral to this process, and we are indebted to them for their collaboration. UMSES uses a 5-step process for creating environmental status reports. The most challenging part of this process is step 3, determining the threshold or baseline against which you are going to compare and score your data. Baselines were determined using a mix of regulatory criteria, established management goals, literature reviews, and expert opinions. Each jurisdiction had workshops where a group of experts proposed baselines that were specific to each indicator in that specific region. The baselines for benthic, fish, and climate indicators were chosen to represent the best available historical or pre-human impact condition. Keep in mind that oftentimes the best available data were post the 1990s, so we have to be cognizant of a shifting baseline when we look critically at these scores. Human connection surveys baselines were chosen via resource manager and stakeholder expert opinions, as there are no standard thresholds for how aware someone should be about threats to coral reef ecosystems. Data for the Pacific jurisdiction status reports were from 2012 to 2016, and these are meant to be informational snapshots of coral reef ecosystem status pre-2017, which we can use as baselines for future assessments. These 5 reports, Hawaii and the Northwest Hawaiian Islands, Guam, the Northern Mariana Islands, American Samoa, and the Pacific Remote Island areas, were released in December 2018. For the remainder of the slides, the color bins for the scores will be as follows and were consistent for all the reports. I won't read them all, but for example, the darkest green is the highest category of very good, meaning the indicator is unimpacted or minimally impacted compared to its historical baseline. In contrast, the red is the lowest category of critical, meaning the indicator is severely impacted or has declined substantially compared to its historical baseline. Here are the scoring wheels for all the indicators for each Pacific jurisdiction. In the interest of time, I won't talk about each of them in depth, but I'd like to highlight some key messages. With respect to the fish indicators, remote places and those with protections, like the Northwest Hawaiian Islands and the Pacific Remote Island areas, have much healthier and more robust reef fish populations, shown by that dark green very good score, than the more populated jurisdictions such as Hawaii and Guam, where you see the orange impaired fish scores. Climate is already heavily impacting the reefs in the Pacific, particularly in the Northern Mariana Islands and the Northwest Hawaiian Islands during their reporting period. And human connections are generally strong in communities in the U.S. Pacific jurisdictions. When we combine the scores of all the Pacific jurisdictions into one U.S. Pacific Basin score, we found that overall climate scores were impaired during the reporting period. Frequent, severe heat stress led to coral bleaching and mortality, and water chemistry is already becoming less suitable for reef material growth. Corals and algae were fair overall, but that reflects a range of degraded to pristine reefs throughout the U.S. Pacific due to both local impacts and global climate change. Fish indicators were fair overall, also reflecting inclusion of very remote reefs that are not subjected to fishing pressure, as well as highly fished reefs. Human connections were good overall. Residents appear to be aware of threats to coral reefs, show support for coral reef management, and seem to engage in pro-environmental behavior. For the Atlantic reports, data used were from 2014 to 2018. This means they are not inclusive of data on the appearance of stony coral tissue loss disease in the U.S. Virgin Islands and Puerto Rico, which occurred in 2019, nor the continued southward progression of stony coral tissue loss disease in the Florida Reef Tract. However, they can be used as an informational snapshot of coral reef status post the 2017 hurricane season and pre-stony coral tissue loss disease emergence in the U.S. Virgin Islands and Puerto Rico. These 5 reports, including Florida, Puerto Rico, including both an English and Spanish version, the U.S. Virgin Islands, and the Flower Garden Banks, were released in May 2020. Here are the scoring wheels for all the indicators for each U.S. Atlantic jurisdiction. Again, in the interest of time, I won't talk about each of them in depth, but I'd like to highlight some key messages. The Flower Garden Banks in the Gulf of Mexico really stands out here as a reef system in good condition, which is a very good news story. This was the highest score of any U.S. coral reef area, and this is likely due to its distance from shore. It's over 100 miles offshore off the coast of Texas, and its deeper depths, which may provide cooler waters and a potential buffer from some stressors facing shallower inshore reefs. In the other Atlantic and Caribbean jurisdictions, we see that fish sustainability is often critical, and human connections are often impaired. When we combine the scores for all of the U.S. Atlantic jurisdictions into one Atlantic Basin score, we found that corals and algae were fair overall, but vulnerable to further decline, in part because Atlantic corals are experiencing a multi-year outbreak of stony coral tissue loss disease, an infection unique for its geographic range, rapid progression, and high mortality rate. Overall, fish populations are experiencing heavy fishing impacts and were impaired overall. The data suggests that the removal of commercially and recreational important fisheries is not sustainable for future populations. In these territories, human connections were impaired overall. The data suggests that residents demonstrate moderate support for coral reef management, but have limited awareness of coral reef threats and rarely engage in pro-environmental behavior. These reports were intended to be used as a communication, education, and outreach tool and provide a high-level overview of coral reef health and status for all of the U.S. coral reef jurisdictions. We wanted to help readers visualize the range of coral reef conditions and also offer some good news. There are U.S. coral reefs with a good score. Most U.S. coral reefs, however, received a fair score, and when there was an impaired score, NOAA's Coral Reef Conservation Program and partners have initiatives in place to help change the trajectory of coral reef health, such as actively restoring coral populations and reducing land-based sources of pollution. Specifically, in this project, we wanted to design a product for people that are actually making decisions on funding and policy for coral reef conservation about how coral reefs are really doing. We got confirmation that policymakers found these reports useful when, during a congressional hearing in the United States House of Representatives in May 2021, they were referenced directly by a member of Congress. Thank you for your attention. I know there wasn't time to dive into all of the reports and indicator scores, so if you're interested, I encourage you to please visit our website and look at the reports and accompanying methods documents to learn more about exactly how we scored every indicator. All NCREMP data are free and open access. I look forward to receiving any questions.
Thank you, Dr. Erica, for the sharing. And now we would like to mark this moment with a virtual group photo. So may I kindly request everyone to switch on your video. Okay, may I ask the the admin team to assist?
Right. Okay. Everyone ready? 1, 2, 3. All right. So we have a lot of guests and participants today, so we have to take another one on the second day. Okay. Keep smiling. All right. Next page. 1, 2, 3. All right. Thank you so much.
Okay, great.
Yep. Thank you, everyone. Now I'm sure everyone is looking forward for this session, and it's my pleasure to pass over the session to our moderator, Dr. Malau, from the University of Philippines, to head the session. So the session is yours, Dr. Malau.
Thank you very much, Nithya. Good morning, everyone, and welcome to Decade Action Incubator 1 on Ocean Solutions. Our focus this morning is to understand the multiple stressors in coastal ecosystems and provide solutions that benefit people, nature, and the economy. Before we start, some additional house rules. Each speaker is given at most 10 minutes for his or her presentation. We have to follow the schedule as much as we can because we have 3 ongoing parallel sessions and participants may wish to join in or move to other sessions. Now that we're all excited, let us begin. We have 6 presentations this morning. Let us start with a bang with our first speaker. He is Professor Zulfiqar Yassin, who is currently an honorary professor and an academic board member of the Center for Marine and Coastal Studies in the University of Science, Malaysia. He has been involved with IOC-WESTPAC in addressing global issues such as ocean acidification and marine plastic pollution. He's currently working on the impacts of climate change on Malaysia's natural ecosystems. Professor Zul's research interests have been on ecology of coral reefs and benthic ecosystems and addressing the issues that affect them in various scales. Ladies and gentlemen, I give you Professor Zulfiqar Yassin.
Thank you, Prof. Malau. Nice to see you again.
Me too.
Members of IOC-WESTPAC and scientists that are here today. I'm going to go from global scale that Erica mentioned to some very local scale. And the topic of my discussion this morning is to look at translating climate change science to the local narrative. What is important is that we did discover in our discussions with policymakers and the public and non-scientific groups, communities at large, that there is a disjuncture, a break between the understanding of climate change. Everybody is almost on board about climate change, but still do not know how to interact and engage with climate change, especially in the fields of marine science and that of finding solutions for much of the problem. So if I may proceed, there is an idea. The idea is to set up a model marine sanctuary to show people that how this can be done and to get people on board to actually achieve something by the end of 2030, almost the end of the or the end of the year of the decade of the ocean. this raises the quality with the objective of raising the quality of life and creating a blue refuge for the protection of our natural systems. We wanted to dive at the deep end and propose one of the most highly populated sites in the Straits of Malacca to create an example which can be perhaps duplicated in many areas. As what was pointed out by Prof. Eileen today, each country will propose a location that they wanted to work on. So we chose the Middle Bank Marine Sanctuary. This is in the Straits of Penang. As you all well know where Penang is, but the location of the Middle Bank is relatively not well known. So it is between the main island and the peninsular Malaysia in the northern Straits of Malacca. Right. So what is in the Middle Bank now? If you look at it, there are several ecosystems there, which are important actually for the sustenance and resilience of the total area. It is next to a World Heritage Site with a big population of 1.7 million. That's the population of Penang. But both sides of the bank immediately is about 800,000 residents. So it is very highly populated. So we wanted to use the Middle Bank for education and for several objectives that could be useful for understanding and finding solutions for climate change. The total area of the Middle Bank is about 14 kilometers squared, which is quite a sizable portion of the second smallest state in Malaysia, which is Penang. Most of it is the marine areas, with less than 1% of an island, which is an artificial island south of the project site at Pulau Gazumbo. So this suggestion was also based on that the island has been quite stable. This is a map of the island in the 1830s while the British were here. And the Middle Bank can be seen in that purple area. It has shifted somewhat, but more or less it's quite stable in the Straits of Penang. So it has been referenced culturally, as you know that the Georgetown area is a World Heritage Site. So to have a blue lung next to a World Heritage Site could actually inspire some of the groups to join us. And as you will see later, it does engage quite a number of non-scientific groups to come up with reasonable solutions for the protection of the ecosystems. Right. Now, what is the area used for now? It is, like I say, it's a built-up area. It's used for artisanal fisheries, which is important, sports fishing, aquaculture, and so on. It's also used for research, and it is an important monitoring site for the country. It has marine traffic. It's a busy port area. There is a bridge that connects Penang to the mainland, and then there are several ports in the vicinity. We started out by looking at what can the Middle Bank provide apart from climate resilience and adaptation. It is useful for conservation, protection of fisheries, carbon trade-off and offset programs, coastal protection. And then we found out that the Penang state government has its own aspirations with respect to greening the state, which could be brought on board. So this is a quite an encompassing project. Although we have our objectives, there are other groups within the state and the nation who are interested in pushing for certain useful agendas. So this coincidence is quite useful in helping us go ahead with the conservation plan of the Middle Bank. Right. So this gives us a chance, actually, when we chose this site, to engage communities and also to bring together several needs. For example, if you turn Middle Bank into a marine protected sanctuary, that would give us a chance to clean up the ocean in that particular area. It would give us a chance to put up several national monitoring stations, which could be compared for long-term data sets. It gives us a chance to look at the communities using that area and how they might understand what could be used from this particular area to push for conservation and their particular needs. This later on could be scaled up to other areas of the nation or even in the region itself under IOC-WESTPAC. Right. There are many teams to be engaged. So apart from the usual marine ecologists and chemists, we have engaged remote sensing experts. There are planners and policymakers, environmental economists. Not all of them are from the universities. Many are from NGOs and also from the state government who is on board. I will show that to you in a minute. I think it is important to get them on board very early on because they are the ones who's going to translate the science into policies and also to community engagement, right? There is a synergy, as I mentioned before, between the state government of Penang, the federal government, of course, publics and NGOs are on board, and the University Science Malaysia is the key scientific agency here, together with international partners such as IOC-WESTPAC. So although we have interest here, there are many other groups who can contribute largely to the sanctuary itself and push for the importance agenda, including climate resilience in Malaysia, right? So one of the key areas that we wanted to look at when we engaged the state government was this Penang 2030 vision, which the state government has put forward in a couple of past few years, right? And by turning that area into a marine sanctuary, we will actually engage 11 of the 18 targets for the Penang state government. So they are very happy that the scientists are working together with them. So our their management decision would be based on firm or hopefully more strategic scientific data in that particular state, right? And also by turning Millbank into a sanctuary, we would have engaged 10 of the 17 SDG goals, which I think is important for IOC-WESTPAC as well. Finally, I would like to say thank you for giving us this opportunity to be able to join you today. And I really look forward for bright ideas, which I'm sure will be put forward by colleagues who have worked in much of the area in the region in the past. Thank you too to IOC-WESTPAC, Wengzi, and the moderator, Nitya, back to you.
Thank you, Dr. Zol. Thank you for presenting to us a marine sanctuary scenario as a possible ocean solution that will address local, regional, and global problems or issues. Thank you very much. Is there a burning question? We have 1 minute left that anybody want to ask at this point. Otherwise, we can reserve all the questions at the end of the session. Best and knowledge sharing. Thank you, according to one comment. Thank you very much, Dr. Zul. Now let's go to the second presenter. Our second speaker is Dr. Udhi Eko Hernawanan. He's the acting director of the Research Center for Oceanography at the National Research and Innovation Agency in Jakarta, Indonesia. He's also executive secretary of the Project Management Office of CoreMap CTI and heads the Marine Vegetation Ecology Research Group. His research has focused on seagrass ecology, marine ecology, population genetics, and species distribution modeling in tropical marine ecosystems in Indonesia and the Coral Triangle. Dr. Hernawanan, the virtual floor is yours.
Thank you, Maria. Let me share my screen. Can everyone see my screen?
Yes.
A very good morning, everyone. And I would like to thank you all so that I can present or share my presentation here in this excellent session. Today I would like to talk about a case study of resilient seagrass meadows in one of the island in Indonesia. It is a small island, and we may learn something about how we manage resilient seagrass meadows in this island. First, I would like to show you where Pari Island is. It is a small island in Jakarta Bay. So it is close from Jakarta, about 45 kilometers from Jakarta. It is small. The total extent area of this island is about 0.41 kilometers square. But the populations living in this island is relatively high. More than 1,000 people living in the island. And this island is one of main tourist destination in Jakarta Bay. Before COVID-19, the number of tourists per week exceeds 1,000 tourists. It can reach 1,500 tourists per week. So as you can see from the map, that is the Pari Island is in the yellow box, the northern part of Jakarta Bay. To put it into some perspective about Jakarta Bay and about this island is under highly anthropogenic pressures because it is close to Jakarta, and we know that Jakarta and its metro area is the world's second largest megacity, 30 million people living in Jakarta and its surrounding cities. And then also with 13 river mounts, daily land derivative marine debris release into this Jakarta Bay, and its effect Pari Island as well. Recent study estimated about 23 tons of land derivative marine debris release into Jakarta Bay. So you can see how anthropogenic influence or pressures on the islands within the Jakarta Bay. About seagrass meadows in Pari Island, it is a mixed meadows, multi-species meadows. There are 7 species, but the most dominant species in these islands for decades, long-term monitoring decades, recorded Thalassia hembrichii. Sometimes Cymodocea rotundata, but most of the time the dominant species is Thalassia hembrichii. And then this is the map of the seagrass habitat. In 2004, the mapping using remote sensing techniques recorded a seagrass extent of 213 hectares. And then the coming years, there are some changes in seagrass extent, but in 2016, the mapping recorded an increase in habitat extent, about 28%. So the habitat extent increased from 213 to 273 hectares. Most of the seagrass habitats are around the coastlines and the in the intertidal areas of the island. Seagrass percent cover. Our monitoring activities recorded some changes, dynamics of seagrass percent cover. But if you compare from 2015 to 2018, within 3 years, there is a significant increase of seagrass abundance or percent cover from about 14% covered to almost 25%. And this increase, we believe it is related to what our conservation effort that we have done in this island. What is the important feature on seagrass meadows in the island is the dominant species is Thalassia hembrichii. And Thalassia hembrichii is a persistent species. What makes it important for a persistent species is that it has high physiological resistance to disturbance, and it is long-lived species. I mentioned Thalassemia hemorrhagiae here because later I will I will show you about transplantation effort, and it is related to Thalassemia hemorrhagiae. So the conservation effort to preserve seagrass meadows in Pari Island is first in 2012. Habitat protection was established on the southern part of the island, and it was about 56 hectares. And the habitat protection is protection mainly from fishing and tourism activities. But it's not only for seagrass, but also other ecosystem like coral reefs as well. And then for the second conservation effort we did is that transplantation. And the aim for the transplantation is that we would like to increase the percent cover of the seagrass, and we aim to reconnect fragmented seagrass patches using a single or multi-species transplantation. And we did it more than a decade, and result was that the increase of seagrass extent from about 28%. And how we did the seagrass transplantation, we called the method Lingis. It means we use a very simple method. It is low cost and applicable to various kind of substrates, from muddy to sand, but it only applies to intertidal meadows. So the idea is a simple, low cost, but applicable to many kind of substrates. Who did the transplantation? We aim to engage a general public to participate the seagrass restoration, and it was successful. We create an ecotourism event or voluntary tourism, school excursion, and then also increase public awareness. So the idea is how we can cut the cost of seagrass transplantation by engaging a wider public participation. So to conclude, seagrass meadows in Pari Island shows resilience amid the anthropogenic disturbance, and the key features in the resilience of these meadows is important species traits, also habitat protection to protect the habitat quality, and also a transplantation effort. For this transplantation effort, we show evidence that the effort helps maintain seagrass persistence in Pari Island. Thank you, moderator.
Thank you very much, Dr. Woody. Thank you for sharing with us a specific solution for a seagrass environment, which involves not only protection from fisheries or tourism, but also, more importantly, the involvement of the public in the transplantation effort. So there's a push for capability building in that regard. Thank you very much. Any questions? I'm reading through the chat. So we have 1 minute. Any question for Doc Odihi? Okay. So there are questions for Professor Zul, but we'll move that to the end. Okay. All right. Let's continue with the third presentation. So the third speaker is Dr. Teresa Ferreira. She is an assistant professor at the University of the Philippines Marine Science Institute. Her research experience and interests span a wide range from red tide or harmful algal blooms to multi- and transdisciplinary work on marine biogeochemistry, eutrophication, ocean acidification, blue carbon, and science communication. It is my pleasure to give you Dr. Ferreira.
Thank you very much, Dr. McClone. And I would like to share my screen now. Okay. Can you see my slides?
Yes.
Okay. So thank you very much again. So good morning, everyone. Thank you for attending this talk. And I would like to express my gratitude to our organizers and moderators for inviting me to be part of this incubator session. So this morning, I would like to share with you a case study in the Philippines that could hopefully contribute to ocean solutions in the West Pacific region. So I will present the issues, impacts of stressors, and possible solutions for coastal waters heavily influenced by mariculture in Bolinao, Philippines. So where is Bolinao? It's in the northwest part of the Philippines, where there is mariculture of milkfish or chanos, and that are being cultured here in the shared waters of both Bolinao Municipality and the Anda Municipality. And the structures, the cages and pens may be found in this boxed area. So the high demand for milkfish has resulted not only in intensive and extensive mariculture activities and degradation of water quality. So what do we mean by intensive? Meaning there is a very high fish feed input because the fish farmers or even the caretakers, they are thinking that if they feed the fish with a lot of fish feed, they will grow faster. But actually, the water quality has been deteriorating, and the cycle of rearing the fish has decreased to about 1.5 cycles to when the water quality is better, where they can where they can have 2 to 3 cycles in a year. So this is how much the fish feed input that is being contributed to the waters. And extensive meaning even the channels are blocked by the different structures of cages and pens in Bolinao and also Anda. So it has resulted to eutrophication that slow down the flow the flow in the channel. And during a major fish kill in 2002, not only milkfish died, but also other organisms, even reef organisms. So it resulted to huge economic loss. And this highlights, I would like to use the term cultural eutrophication because it's really the people, it's really us or the humans who are accelerating the increase in the concentration of nutrients and organic matter in those waters. So if you look at this shaded portion here, so this is the time when the number of structures have been reduced to the carrying capacity level in the Bolinao municipality. And even if that was implemented, the concentration of nutrients remained high. And the causes here in the right are the ones that are being thought of as reasons. And we studied actually these topics and during the sampling, during those sampling periods, we experienced algal bloom during sampling in the wet season. And you can see actually the streaks of algal bloom here in the waters of Bolinao. Okay, so we collected several samples and this just shows you the end member sources of the nutrient inputs and organic matter inputs to the mariculture waters. And aside from that, we also have a continuous and comprehensive monitoring station where we have a lot of sensors that were deployed, which started during a collaboration project with Japanese researchers. Okay, so based on our study, so this just shows that there is seasonal variation, the figure on the left, and the figure in the middle just shows that the N2P, just using the N2P ratio, we can say that the major source of nutrients in the water column are the decomposition of of wasted feeds, fish feces, and fish excretions. And these are the N to P ratios from literature that we got. So the 6.6 ratio that you see at the bottom waters during the wet season correspond to the N to P ratios of these sources, like the excretions, feces, and fish feed. Okay, so what we want to do is to really understand what is happening, what's causing the algal bloom, what is fueling the occurrence of algal blooms. And this just shows you the different sources. And during the dry season, there is nitrogen limitation because of abundance of phosphorus from decomposition products. And during the onset of the wet season, we have supply of nitrate. And that supply of nitrate will cut or will stop the nitrogen, will result to algal blooms during the start of the wet season. Okay. And another reason of this sustained eutrophication is because, based from satellite images, the number of structures are increasing not only in Bolinao but also in Anda, so another municipality. So there should be inter-municipality efforts in improving water quality. So even though we have those kinds of results, there is still a gap between science and policy, and this could be because of the form of data presentation, which are not easily comprehensible to our stakeholders, and limited time for science communication efforts, as well as limited activities on creation of science-based policymakers. So a possible ocean solution one is the ecosystem health report cards, and I'm happy that Dr. Erica Toli has already introduced this. No, so this is we are creating an ecosystem health report card for Bolinao and Anda, which can also be actually created for different other water ecosystems like coral reefs and other bodies of water. So it's an assessment. It's essentially a science communication product that is similar to a report card that reflects the scores, which can be communicated to decision makers and the general public. So if we compare a school report card to the left, so we have our subjects, we have our grading scale. In terms of the ecosystem health report card, we have our water quality indicators. And if we want, we can also have fisheries indicators and other indicators that we would like to include in the card. And then we also have descriptions of the grading system, and this color coding scheme, like the traffic light, has also been introduced by Dr. Erica earlier. Okay. And we want to do a report card because we want to relay the story, the problem, and the possible management action. So I think awareness is the start of accountability, and followed by action. And then it can be available in local languages. And this has also been mentioned earlier, the different steps in creating a report card. So to do that, we did a stakeholder meeting that involves different stakeholders, participants in the Bolinao Anda, and we actually expanded it to the neighboring municipalities like Bani and Alaminos. We also asked some champions to speak with our stakeholder, and we also described to them how this report card process is being made. So I asked them to identify the values and threats, and we listed them here, the values on the left and the threats on the right. And after identifying this, we created this conceptual map of what is really happening, of the values and threats. So you can see here sedimentation, invasive species, nutrient input, which can also be expanded. You can add more images to further relay what's happening in the system. And after that, we would like to choose indicators, again, as a result of the stakeholder meeting, and then identify the thresholds, because these thresholds will eventually help us to get indicator scores. And if there is category, we can insert category and get the overall score, which is a number, and convert it to grade eventually, which is easier to remember compared to the scores. Okay, so for this ecosystem health report card, we would like to combine scientific and traditional knowledge we would also like to include local language in the report card. And actually, there should, aside from the report card, there should be different science communication tools for different stakeholders. Like, for example, children's book or storybooks for different ages about environmental problem, flyers, and policy briefs. Because eventually, towards the end of the decade, they will still be involved in the problem, and they would probably have transferred to another age group or a stakeholder group. So, okay, second, this will be briefs. The second solution is to incorporate human inputs into models. So there's a recent paper that incorporated the decrease in fish feed input into hydrodynamic and seagrass models, and after that predicted that there could be an increase of above ground biomass with improvement of water quality upon reduction of fish feed input. And scenario 1 is only one municipality, scenario 2 is the other municipality, and scenario 3 is the combined efforts of municipalities. And this just shows you that so more increased ratios of above ground biomass, reddish and yellowish areas. So if there is increased combined efforts, there is increased improvement in water quality and also above ground biomass of seagrass species, dominant seagrass species in the area. However, its effect on carbonate chemistry is has not yet been studied. Actually, how do we relay, or how do we relate this to the recovery from ocean acidification? That would be an interesting topic. Another one is the creation of transdisciplinary research that involves livelihood. So this shows the overlap of disciplines like the monitoring, continuous monitoring of water quality, and others that are related to ocean health and bioremediation. So we also study organism not only for bioremediation but also for livelihood. And we can also incorporate the social aspect, like how do they perceive this pollution problem? How can they change behavior so that we can all help in the improvement of this water quality? Okay. And another one is adaptive governance. No, so this is a framework that is can be seen in this recent paper, and this could be site specific but good example of science-based adaptive management. So for example, we can include a carrying capacity of municipalities that share coastal waters. For example, only Bolinao, I think, so far has the carrying capacity calculated for their area, but not the other adjacent municipalities that share the same coastal waters. And this is an interesting study to do, the environmental justice, to justify recovery from cultural eutrophication. And this is the last one, is the sustained engagement efforts with stakeholders. To determine the science we need for the ocean we want. Actually, the science could be combination of natural and social sciences, and we here in this incubator session could be only a small percentage of the big group of stakeholders that we need to share our results, our ideas for the collective efforts towards achieving the societal targets of the decade. So that is all, and this is just a summary of what I have presented. So thank you very much, everyone, for listening this morning.
Thank you very much, Dr. Cha, for giving us an eye-opener of many possible ocean solutions, no? And foremost of which would be what you listed, and included in those are, or possibly is, a collaboration between adjacent local governments that share common waters. Okay, we have to move on to the next. We'll reserve questions for Cha at the end. The next speaker is Miss Varintha Vasinamekhin. She's a fishery biologist with the Department of Marine and Coastal Resources under the Marine and Coastal Resources Research Center, Upper Western Gulf of Thailand. To talk about her work in the Upper Gulf of Thailand, I give you Miss Varintha.
Thank you so much, Dr. Maria, for introducing. I will share my screen.
Go ahead.
Hello, everyone.
Yes.
Today,
Mm.
okay. Today I'm going to talk about high productive ecosystem under pressure from anthropogenic activities of the Upper Gulf of Thailand. The Upper Gulf of Thailand is an area comprising of several types of ecosystems. For example, mangrove along the coast, coral reefs, and sea grasses in the eastern part, and a habitat to important marine species such as short mackerel, dolphins, and whales. The Upper Gulf of Thailand is also a core economy of Thailand, having several activities in the area, such as aquaculture, fishery farm, agriculture, and tourism. So this area is important as a source of income for the communities in the coastal area. High productivity in the coastal area supports rise of the local people for centuries. In recent decades, it's due to socio-economic development. Thailand exploits marine resources for manufacturing and export intensively. Regarding marine environment dramatically, this causes combined effect among oxygen deficiency and hypoxia, water acidification, eutrophication, consequences of anthropogenic impact, and overexploitation are, for example, losses of shellfish harvesting and deteriorate coral reef, affecting local economy. Therefore, Department of Marine and Coastal Resources has continually monitored water quality in the Upper Gulf of Thailand for decades. Based on Marine Water Quality Index, it indicates that water quality in the Upper Gulf of Thailand is in poor condition for all estuarine areas, but in fair condition for the other area. High nutrient concentrations showing nitrate and phosphate existing under standard criteria are typical in estuarine areas and in both monsoon seasons. Subsequently, oxygen level is so reduced that it could harm marine animals, especially near Chao Phraya and Tha Chin river mouths. This is typical during rainy seasons as increasing organic rotting from land. One of common problems in the area is eutrophication, which plankton bloom causes by rotting from the nutrients and organic matter from land into the sea. As vast area of agricultural activities and the city in the central part of Thailand, recently resuspended of nutrients from the sediment is also suspected as deposition and accumulation of the organic inorganic compounds throughout the decades. As you can see, red tide occur more frequent since 1997 near Chao Phraya and Bang Pakong river mouths. Occurrences is typical in February, July, and August in every year. In the eastern part of the Gulf, there is coral reef. Climate change and anthropogenic causes may lead to a change in the ocean acidity. DMCR has monitored pH in the reef area for several years, showing decreasing trend of the pH value over past 5 years. Again, this may be subsequent of the freshwater discharge that deliver large amounts of inorganic and organic nutrients into the Gulf. Biological response to the nutrients can lead to deficiency of oxygen, as well as lowering pH in the water, posing pressure onto the coral ecosystem. This is in addition to increasing anthropogenic carbon in the atmosphere. This may be an alarm to the integrative effect between climate change and anthropogenic cause. These are sample cases of the red tide and hypoxia phenomena found in the upper Gulf of Thailand. Red tide and hypoxia phenomena occur shortly in the upper Gulf of Thailand. They are usually found in the end of the rainy season during September to November in every year. The MCR routinely monitor water quality in the area and building network among local communities for their collaborations in managing wastewater and raising awareness in protecting marine environment, as large support information for future decision and policy and propose necessary means to tackle with the pollution problems. Next, requirement to step forward to identifying the causes of the problem and the dynamics in the area by clearly understanding the language among phenomena in the upper Gulf of Thailand and Wachigadem, and applying innovation like real-time monitoring system for the relevant water quality parameters. Last, engaging relevant government agencies, communities, and related parties to achieve in scientific-based solutions to prevent or mitigate impacts on coastal resources, as well as sustaining livelihoods of the coastal communities. Finally, I would like to thank all of you. It's my pleasure being here today to share with you all, and thank you so much to Wensi.
Thank you very much, Ms. Varintha. Thank you for sharing your experience and the various stressors that your upper Gulf of Thailand is experiencing. And more importantly, for emphasizing that establishing networks among local communities and raising awareness is important in tandem with monitoring activities. Any questions for Ms. Varintha? So you have a comment here, a nice and fruitful presentation, which increase our knowledge as aspect of pressure impact on ecosystem. My question is, I think we have time for a question, right? Ms. Admin person? I don't. Okay, I haven't been flagged at time's up.
I think we proceed all with the speakers and then we pull all the questions at the end. Yeah, thank you.
All right, thank you. The fifth speaker is Dr. Vot Tran Tuan Lin, who is from the Institute of Oceanography, Vietnam Academy of Science and Technology in Nha Trang. At the Institute of Oceanography, he is tasked to research and propose solutions to reduce marine pollution towards sustainability. He has been involved with IOC-WESTPAC as a focal person in ocean acidification and microplastics. Dr. Tran, the floor is yours.
Do you see my screen sharing?
Yes.
Okay. Okay, thank you for your kind introduction. Okay, today I will talk about like a very specific case of our ocean solution for our solutions. I will talk about Phuoc Islands, the South Islands of Vietnam, with the challenges and the perplexity for sustainability. Okay, first of all, I will like.
Dr. Tuan, I would like to request you to put the slides on a presentation mode.
Sorry?
Your slide is not in presentation mode.
Where is it?
Yes.
Slideshow.
Yeah, you have to put it in slideshow.
Nó mở full màn hình đó anh ạ. Nó mở full màn hình đấy.
Is this okay now?
No, it's not in slideshow yet.
What is sharing?
Bên hỏi yêu cầu mở full màn hình đấy anh ạ.
Dạ em mở rồi anh ơi. Đang không biết tại sao nó.
Anh dùng chế độ là full screen đấy.
Okay. Oh. Let me see again. Is it okay now?
Dr. Tuan, look on the top. There's a slideshow. Click that.
Yeah.
See, there's a bar which says slideshow. Click that and click.
I did.
No, it's not on presentation mode.
I don't know why. Maybe software. Let me.
Doctor, is it possible I share from my side?
Yes, maybe you should press F5. So it in presentation.
Does the admin have a copy of his slide? Maybe the admin can play it for him.
Already,
unfortunately, no, we don't have a copy.
Yes, I can share for the speaker.
Yes, please.
Okay, thank you. Maybe I will talk on this one. I don't know why I am sharing my screen, but like they have just like very small one. I don't know. Okay, thank you. Should I take again? Okay, next slide. Okay, so I will give a short introduction about my case study here about Phu Quoc Island. It's located in the Gulf of Thailand, including 22 islands, and this one is my country only first one island city. And I will like very short interview with like because of the is a World Biosphere Reserve, and my names for World Biosphere Reserve we have like 42 species of land and 23 species of animal in red list of IUCN. It is the name Phu Quoc mean like prosperous land. You can imagine the introduction through the name like Phu Quoc is prosperous land with 10 hectares of coral reefs conservation area, 12,000 hectares of seagrass beds, and 3,000 hectares of wetland and mangroves. And its other names is like Paradise Island, which is one of the best place for ultimate Asia experience voted by CNN, and it's due to be top 6 of the most beautiful beaches. And another name is Pearl Island. That is very rich and a lot of like pearls, the Pintada maxima here, and now it's counter and processing for the market. And for the ecosystem services profit, we got around 6,000, more than 6,500 US dollar per hectare of coral per year. Okay, next slide, please. Yeah, and for the strategies orientation, Phu Quoc have important role, not only for national defense, but also for socio-economic development. And our Deputy Prime Minister said on the celebration of declare when Phu Quoc go to Island City, he said that Phu Quoc would be an important traffic hub, a center of science and technology research, and biodiversity conservation area. both forest and marine biodiversity. Next slide, please. However, due to the development, we are paying for the cost of development due to the rapid population, tourism development, and urbanization. We give Phu Quoc a lot of stressors, and the anthropogenic stressors, like we can see here, the destructive and over exploitation, and land-based pollution and sedimentation, and also the waste, plastic waste, microplastic waste, and also wastewater. You can see here the goat net on the coral reef and the plastic bag on the coral reef in the corner. Yeah, you can see with the upper picture, like the urbanization here is very fast and very big. Yeah. Next slide, please. We talk a little bit about destructive exploitation. It's not only here in Phu Quoc, but also on a lot of places in our country and also for our region. As you can see, lots here, like a lot of yellow and red dots on this map. Next slide, please. Besides the anthropogenic stressors, we have also like natural stressors. First of all, it's very reserved here is very serious. Here is like the global climate change and ocean acidification. Due to the warmer temperature, yeah, we have like very big, very serious large-scale coral bleaching took place in Phu Quoc in 2010 and 2016. The mean coverage of bleaching were more than 18% in 2010 and 20% of 2016. 90% of shallow reefs were bleached due to long impact duration, around like 3 months, 4 months, and 1/2. Half coral colony died at 2 reefs in the south area of Phu Quoc Islands. And a survey in 2019 found that the acidification situation of this area is not so ideal for coral growth and recruitment compared to other coral reef dominated water. Like in our surveys, we found that peril offshore, 100% of shore sites have the omega values, the aragonite saturated under 3, like the level of the threshold for make stress the coral. The value is just from 2.13 to 2.791, and the coastal reefs mean the nearshore Phu Islands somewhat better. Also, the mean value was still below the stress threshold, with the mean value is around 2.97. Okay, next slide, please. And it's very important to notice that the trees, the stressor and the impacts are often assessed individually. But however, each reef or each area is affected from very different stressors at the same time. So we need in the near future, we need the community effect assessment to find the real causes, the full causes, and to find the adaptive solution. And notably, the reefs that are degraded by anthropogenic stressors are less resilient to the natural habitat change. Next slide, please. Yeah. And what we are trying to do is like this is what the action, the solution from government. We can list here, I can list here like the conservation and sustainable use for coral reef resources. We are trying to do so like, by improving the management efficiency of the MPA. Here is the Phu Quoc National Park. And the restoration marine habitat and resources, adaptive monitoring and management, and establish and develop the effective management models. Like we have some models, some assist model with somewhere is quite effective, like in Tam Islands MPA. So we try to develop and scale up to this area. And the last one in interdisciplinary management and resilience to the chance. That's what we have to do. And this is some achievement. This pond restoration in Phu Quoc and the coral restoration. You can see the picture here. Yeah. Next please. And based on what we try to do, I'm suggest some like prophecy for sustainability. First of all, we need awareness for actions. Like the purpose of this conference. I would like to talk about the ocean literacies that we need. We need knowledge. We need science. We need technology. We need everything. Knowledge base for action or for proper action to develop this area. And this is a chance for us to collect and establish the marine knowledge base, then transmit to the develop and building the civilized behavior toward the ocean. Yeah, you can get more detail about ocean literacy on the WESTPAC network. Next, please.
Dr. Tuan, we are running out of time now. The time is up.
Yeah.
We can wrap up the session so we can save some time for the discussion session.
Okay, so another one is conservation orientation and reasonable use. Like we conserve it. The conservation is for harvest, and we need like coral management and responsible fishery. Okay, next please. I will talk faster. Okay, and we need a sustainable tourism. Like we have some principle here: nature conservation for make different plans for situation for the such situation and responsible use and local community involvement and awareness raising for guides and also tourists. Next, please. Okay, so the at the top I mentioned about we need like waste management, both wastewater and solid waste, and including like microplastics. Next, please. Okay, but like it's a very like a gap here about the emerging issues about the plastics and microplastics issues. We did have the action plan in 2019, but actually we don't have much actionable plans. That we don't have any actionable like very specific plan to solve this problem. And about the ocean acidification, we almost know nothing about here. I mean the government and the MPA here. So we need more proofs to persuade our managers, and we need to shock more stakeholder, business manager, and communities to the scientists to solve this to find a solution. And I mentioned before this workshop, I did contact to farm business over there, and they show their concern. They concerned about like how the pollution impact to their farm and to their pond, and how we can do the research later. They are willing to sign an MOU with us, to make a research center in their farm to do that. Like maybe this will be the ongoing plans. Okay, next please. And I need more discussion to help about this area. Okay, thank you.
Thank you very much, Dr. Tuan.
Sorry for the technical.
That's okay. So Dr. Tuan brought to light once more that threats and inputs should not be assessed individually, and which emphasizes the need to do more inter and multidisciplinary work. And then he also presented approaches for sustainability, which includes ocean literacy and sustainable tourism. Thank you very much.
Thank you. Thank you.
Let's listen to our final speaker. Dr. Liang Zhang is a senior researcher and director of the Key Laboratory of Global Climate Change and Marine Atmospheric Chemistry at the Third Institute of Oceanography under the Ministry of Natural Resources. His research includes biogeochemical cycles of greenhouse gases and their exchange across the atmosphere, sea ice, and seawater, especially in the polar ocean. During the past decade, he developed new techniques for high resolution and precision data archiving of oceanic greenhouse gases. Dr. Zhang?
Can you hear me?
I think you're muted.
Hello, hello, can you hear me?
Yeah.
Can you hear me? Hello?
Yes, but
Hello.
very soft, very soft.
Very soft. Okay, I will try. Hello.
Yeah, that's much better.
Okay, I don't need a headphone. Okay, I will show my screen. Okay, here we go. Okay, yeah, thank you. Morning, everyone. I'm so appreciate that we have this opportunity to share some of our work. And today, what I'm sharing is a hello. Is there someone speaking?
Yeah, yeah, go ahead, go ahead.
Okay, okay, sorry. Here's a case study of our recent work about the marine culture point on and its greenhouse gases emission and nutrient contribution. And here's the contents of this talk, and I will firstly give a brief introduction about the background and description of the study region and show some result and possible solution for this case. And we all know that the river estuary and coastal region are under directly anthropogenic influence, including a high nutrient loading discharge from agricultural runoff and livestock runoff and so on. So high concentration of nutrient will lead to eutrophication in the coastal and estuary region, and then lead to hypoxia and harmful algae bloom. Meanwhile, more recently, the researcher concerned about the ocean acidification in the coastal region. And because of there's a large amount of organic matter decomposed, carbon dioxide tend to accumulate in the estuary and coastal region and result in raising of PCO2 and lower of pH value. Also, it promotes the emission of greenhouse gases like methane and nitrous oxide. And moreover, the floating garbage is another environment problem. Our study area is near the Xiamen, the southeast coast city in China, and adjacent to a estuary, Jurong estuary. And so this region also suffered from the same environmental problem, including eutrophication and sometimes the harmful algae bloom. And there are some locations we do find low oxygen conditions. Also, there's ocean acidification and floating garbage problem. So as a tourism city, people try very hard to improve the environment. So there's a restriction on stock feeding in upstream and removal of marine culture site in open water. And there's a regularly clean up of the floating garbage. So we can see that the floating garbage, the amount of the floating garbage in Xiamen is keep decreasing in recent years. However, the nutrient, especially the nitrogen, DIN in the Jurong River estuary and adjacent sea is still very high. About 10 years ago, it reaches maximum value, and it seems like it is stable through these 10 years. And the HAB frequency is increasing, but decreasing in the past 10 years, but it's still very high. So also there's all these problem result in a high emission rate of greenhouse gases like carbon dioxide, methane, and so on. So we all know that these greenhouse gases is important reason for the global warming, and these 2 years the carbon neutrality is a very, very hot topic everywhere, and we know that reduction of greenhouse gases emission is very important task. So we try to study in the adjacent area in a razor clam pond. It is one of our study in this region, and the reason we studied because yeah, here's some description of these species of culture species. Okay, anyway, the interesting part is that the culture system is different. It consists of algae ponds and the shellfish pond, the inlet water from the estuary, and there was an organic nutrient, organic carbon, fertilizer like an amino acids was added into the algae ponds and to promote the algae biomass. Then the water was, after 24 hours, the water was transferred into the shellfish pond to raise this, to feed these shellfish. And so then after about 10 hours, the water turns green, and the water was discharged from the water flow, outflow. Okay, then we take the samples of greenhouse gases, DOC, POC, nutrient, temperature, and so on. Here's some analysis, the field work and analysis work. So here's the results. We conduct 2 field experiments, and you see that there's a March and April field work, and the weather condition is different. During the March, we experienced a very cloudy day, and during April, the weather is good. It's cloudy, so we can see that there's a dynamic circle of the temperatures, dissolved oxygen, and pH in algae pond and also the shellfish pond. That's because of the photosynthesis and respiration. But in the cloudy day of the March, we don't see that pattern. So for the nutrient, we see that all the nutrient, the total amount of nutrients is decreasing, especially the nitrate. The nitrates keep decreasing from the algae pond to the shellfish pond, but the ammonium decrease in the algae pond, but increase again in the shellfish ponds because of the consume of the ammonium by the algae and release of the ammonium by shellfish. Okay, but for the greenhouse gases, we see that during the cloudy day, yeah, we missed one point in the very front, so we didn't see the the concentration of beginning of the PCO2 and other gases, but we know that it should be very high. But soon the PCO2 dropped to about 200 ppb, but in the April work, we see clearly the downward patterns, and we see the consumption of the carbon dioxide. But the methane is increasing significantly. Okay, so as a total results we show here, we show that the nutrients is decreased in the algae pond, both of the nitrate and ammonium, but there's an increase in the shellfish pond. But the nitrate in the shellfish pond keep decreasing. The total amount of nutrients is decreased or remain stable. For the greenhouse gases, we see that the carbon dioxide is consumed, and in the pond A, in the algae pond, but it's released again in the pond B, the shellfish pond. The methane and nitrous oxide was substantially released, so we can see the total effects of greenhouse gases may come from the methane. So that's a summary of the data analysis. The nutrient is reduced during the culture period. Thought it was the nutrient was adding to the pond to promote the algae bloom. The methane and nitrous oxides, main greenhouse gases, it contribute more greenhouse gases if it than carbon dioxide. Is a calculation, but it's complicated. I don't share here. Okay. For the possible solution, this is what we are thinking now, but it's a study. It's at our beginning stage, so there's something we think about. We will have some maybe more new idea in the coming years. So first of all, we think that we need to the organized fertilizer application should be reduced, because accumulation of this organic matter will result in significant greenhouse gases emission. And also, luckily, these systems, since don't add any nutrients in this river water after they leave the pond, but is there a possible way that we can utilize the riverine nutrient somehow? I change the ratio of the nutrient we apply, or anyway, anyhow. There's something we need to find an answer. And in the long run, we think that restoration of mangrove ecosystem is important, because all this pond was built in a site where it used to be a mangrove region. So, but yeah, that needs to the policymaker and other stakeholders work together to find a solution. Yeah, pretty much that's what we what I'm going to share. And this is our team, field work team. They work together very hard in the field. Okay, thank you. That's what I'm going to share today.
Thank you very much, Dr. Liang. Thank you for sharing with us the suggestion for solutions in terms of improving the management of mariculture and bringing in blue carbon ecosystems such as mangroves to help out. With that, all the sessions, all the presentations are done, and we proceed to the Q&A or discussion. Eileen, you want to take over?
No, thank you. I think you can proceed on, and I can add on to some of the questions. Yeah, thank you.
All right. Okay. I've noted some of the questions. For instance, for Dr. Zoll, this is a question on implementation. on the ground implementation. So is it going to be like project from the university or from the government support, or your thoughts on this, please? This refers to the marine sanctuary.
Right. Okay. Thank you for the question. Yes, the university and also some NGOs started the ball rolling, and by bringing and highlighting some of the issues with respect to the Middle Bank sanctuary. Actually, we initially do not look at the Middle Bank as a sanctuary, but we wanted to improve the environment and the ecosystems in the particular area. The sanctuary was a sort of a solution that arise after discussion. We realized that the scientists are important to provide the initial and continuing monitoring and scientific research and data that is required for the management, but the actual management has to be done by the Penang state government, and the buy-in has to be from the local communities. So very early on, we engaged all these stakeholders, and we wanted to know what were the issues and what were the limitations of each of those stakeholders before we proceeded. And we came up with the idea of setting up a marine sanctuary. We have to say that the goals are set quite high in the things that we wanted to achieve. But I think any move forward is important to be able to show that this is possible. And the buy-in, especially from the Penang state government, is very, very important, because funding and the policies that come from the state government will actually be important to translate into what happens on the ground, of course, plus the support of the local communities. Thank you, Maria.
I have something to add, Maria. For this project, Middle Bank Marine Sanctuary, for your information, or for the information of the audience, is already an ongoing. We have passed the stage of proposal. We have managed to get the buy-in from the government, as well as now we are working also hand in hand with the local community, local NGOs. So it can be used as a hopefully it can be shared as a success story in the next round of reporting. Yeah, thank you. Back to you, Malio. Hello.
Thank you for that. I think marine protected areas or sanctuaries are the way to go, no? Although it will involve a lot of buy-in from the various sectors, especially from the government. Another question is for Dr. Udi. This is regarding the monitoring of the seagrass conditions after transplantation, because this is an approach that you did in Parry Island. So what happened to the seagrass after transplantation? Are they living, or are they doing well, or Dr. Udi?
Yeah, we did monitoring after the transplantation, and currently the last monitoring was last month. Yeah, it was last month. And we found that the survival rate is higher in a mixed species transplant compared to a monospecies transplant. So that's one of our findings. So that means it is better for the transplantation effort, it is better to do a mixed species transplantation instead of a single species transplant. Yeah, so yes, there are plans for monitoring after the transplantation.
Okay.
Thank you.
Thank you.
Can I invite Yang Xiang Ao, who has posted the question on citizen engagement, to share a little bit on the question? Yang Xiang, are you still around? If not, maybe I would like to invite also Zhen Guanzu from WWF to comment, to give some comment on your experience with working with stakeholders. Zhen Guanzu. If not, we'll wait for a while. I'll pass it back to you, Malau.
Okay. Can we proceed to the next question?
Yes, yes.
All right. So the next question is for Dr. Cha. How different is the Ocean Health Index from the Ecosystem Report Card?
Thank you for the question, Dr. Zhu of WWF. Actually, you can include the Ocean Health Index in the Ecosystem Health Report Card. The considerations for choosing indicators for your health report cards they are SMART, so they are sensitive, measurable, available, relevant, and they have to have thresholds. So good indicators are well documented, and you have to have thresholds so that you can convert the, for example, numerical value of the parameter into percentages that can be used to compute the grades in that specific area or location or site that you are doing the report card for. So you can include actually the Ocean Health Index in your ecosystem health report card. So they fall as categories of indicators. So you have the indices. I hope that answers the question.
I think you did answer the question well. Thank you. The next question is for Ms. Varintha from Jan Mohammed. Are you still here? The question is pressure affect all ecosystem on sea animals and or some species? So I think this refers to if the stressor is also affecting the other components of the ecosystem. Is anthropogenic impact affecting everything? In other words, sea animals and other species. Ms. Barintha? Or Jan Mohammed, you're here. You want to explain your question a bit? Jan? Well, Ms. Varintha, you want to reply?
Hi, I'm John Mohammed from Pakistan.
Yeah.
Hello?
Yeah.
Yes, Jen.
My question is that the pressure impact on all species of ocean animals or on a particular species. That means we can say that temperature and pressure affect on some fishes, type of fishes or some type of species of ocean. Or these pressures affect all animals of oceans or some species or only some species.
Ms. Varintha? Okay.
Sorry, are you with us?
Sorry. All right. Are there any other questions? We have 1 minute. There's a comment here from Jan Mohammed. Eileen?
Yes, yes. Okay, can I just have a comment from because I see in the audience we have lead players, you know, in the side research of multi stressors and research. Can I get Suchana to comment a bit on what is your thoughts on ocean solutions? Suchana? I see the name there, but
There is a comment from Pak Zainal, Eileen.
yeah, Pak Zainal, can I invite you to share your thoughts on this?
Okay, thank you. I just sent actually in the chat. I thought that I think it's really excellent presentation from 5 speakers, yeah, and from different countries. So each country has unique issue actually, but almost a common topic, yeah, about multiple stressor. So like from Penang issue from Professor Zulfikar on the issue of ocean acidification, while from Indonesia, from Pari Island about marine litters, and from Bali now about nutrient, also from Julong estuary, yeah, about a nutrient issue, yeah. Fukuok also about a nutrient issue. I think it will be good if we have a kind of regional network, Prof. Eileen, yeah, and
Yes.
Maria, to develop what kind of comprehensive solution. I think Carissa suggests about modeling. That's really interesting, I think. How this nutrient issue and also marine litter can be solved by using a modeling process, modeling, yeah, and also from location in Julong estuary. I think the solution is also quite interesting from my perspective. Right? So how nutrient from a river was used as a solution. It's really interesting for me. Thank you very much.
Thank you, Pak Zainal. I think Pak Zainal has more or less helped us to summarize, you know, or the information shared by the presenters. Yes, the invited speakers, you know, of their own field and expertise, they share their resources, they share the expertise, and they share the ways they champion the ocean solution in their respective areas and respective countries. Following to that, you know, due to lack of time, we cannot proceed on with more discussion. For the information of all speakers as well as all the participants attending here, the convener of this incubator, we will compile and summarize all the comments been put in together with the presentations and the suggestions, and then what we'll do is we'll put in for a discussion with IOC-WESTPAC, and we will plan to see how we can move forward together on not as per country, but as a regional effort on moving towards ocean solution. For the benefits of people, nature, and the economy. I think we are very tight on time. I think that is all I can wrap out. Pass back to Mario. Mario, you have anything you want to have a final say on the program itself?
I just want to thank everybody for your contribution. The session went very well, I think, and thank you so much for sharing the presentations. And I think the local ocean solutions are in place. So what we have to do
Yes.
now is to think of regional solution, regional ocean solution. Thank you very much.
Thank you. I would like to invite Wingzi to have a final wrap up. Wingzi,
No,
1 minute for you.
So,
Okay, thank you.
No, I just say, today I think, although, only 2 hours, I think indeed represent a very good beginning for the regional community. I mean, including our research community to work together, not only to understand the issue, but also more importantly, provide possible solution. So this is I think the incubator title precisely, point out the clear direction that we want to go over the next decades. So I think as the two distinguished moderator and also speakers emphasized, it's very much important for us to start to network together and also build on the good work has been done, not only on science, but also on other parts, like the public engagement, like the stakeholder, the policy and also science interface. I think from today, the 6th case study indeed provide a wonderful case study for us to, to further build our future, ocean solution program. Thank you very much for the very excellent presentation, and thank you very much for Eileen and Professor Zalfiga and also Malo and also all the organizing team for such a kind of a very wonderful incubator session today. Thank you, Eileen.
Thank you. Nitya, back to you.
Yeah, thank you very much, Dr. Malo, Professor Aideen and Wenzi for wrapping up this session. And we would like to thank all the speakers, moderators, and participants for joining us in the Decade Action Incubator 1. We hope that sessions are fruitful and beneficial to all. Please continue joining all the interesting Decade Action Incubator series lined up today and tomorrow. And do join us in the opening and high-level segment later today at 1 p.m. Bangkok time. So with that, we'd like to say have a great day and take care. See you soon.
Thank you, everyone.
Thank you, everyone.
Yeah. See you in the next session. Bye.
Thank you very much.
Thank you, everyone. Bye.
Thank you.
Bye.
See you.
See you next session.
Thank you. Bye-bye.
Bye.
Thank you. Thank you.
Congratulations.